Today we will be discussing about ionization versus recombination and spectral patterns and relevance with astronomy. So we see this incident photon coming in and ionizing this electron, which the electron is escaping from the atom. So how does this happen? Well, the photon's energy has to be equal or greater than the binding energy. And as long as these conditions satisfy, the electron can be ionized from the atom. There isn't a specific energy needed to ionize this atom, only the binding energy condition. So now let's move on and define ionization. When an electron is ionized, we mean that a photon is absorbed. Also, the electron is freed from the bound atom. For recombination, we mean almost the opposite. In recombination, the electron is captured. And photons are emitted as electrons fall down to lower levels. To make it more clear, let's draw a diagram, starting with ionization. So when the photon is absorbed, this is the photon going here, and we have the energy levels, level 1, level 2, 3, 4. The electron is right here, and once the photon comes in, it frees the electron from the bound atom. So let's define this as E1 equals 0, E2 equals 5, E3 equals 7, E4 equals 8. And then for recombination, we have the same energy levels right here. The electron falls down to the uppermost energy level, and this is E4 equals 8, E3, E2, E1 with the same values on the left hand side. And once it falls to the highest energy level, it gradually makes its way down to the first energy level, and in this process the energy of the photon is being emitted, so it gradually loses energy as it goes down to the lowest energy level. While on the other hand, the electron, starting from the first energy level, increases its energy as it goes to higher orbital levels. So now we're going to discuss about the spectral patterns. Each element, an ionized element, actually produces a pattern of lines like your fingerprint, in which we can identify the elements in our universe. We call the spectral pattern. Using the unique pattern of lines, we are able to determine which compounds, which elements are on which planet or star. For example, for the hydrogen spectrum, we have something that's like this, where the dips represent the Balmer and Lyman series, something we will learn later on, but this is a rough sketch of a hydrogen spectrum fingerprint. Now we're going to address the last component of today, and that's the energy of the photon absorbed. So how do we calculate that? Simply, we can calculate this with HF, or HV, as you may have seen it, and that is equivalent to Hc over lambda and the change of energy, difference between the energy levels. So I hoped this episode provided you a better understanding of ionization and recombination. In our next video, we will be discussing about Doppler's effect, so stay tuned for that. Thank you for watching.